Take two. I messed up a while ago. I have to start over. So we're going to do some calculations here involving force, pressure, and area. And let's start out with that calculation. We want to calculate the force of the extended. We're going to calculate the extended force, and we're going to calculate the retracted force. The extended force will come from this pressure here, pushing the rod out this way, which will close the bucket on a backhoe or an excavator. Now, the subtracted force will be this force where the fluid's coming in to this side and pushing it this way. Now, I don't know if you've operated a backhoe or an excavator, but the closing of the curling of the bucket is probably the most powerful force on the piece of equipment. And look, it comes in on the blind side, they call it. Notice this is just a flat circle if you're looking at this with nothing else. You get to count this as a 4-inch circle that's flat. Over here, however, we don't have, even though the piston is the same size on both sides, we have a 2-inch circle taking up space or using up area of this side on this side. So the force over here is going to be less than the force over here. This will be the retracting force, which is opening the bucket. This will be the extended force, which is closing the bucket, which is much greater than the retracting force. If you recall, I may have said this over and over again, but when you curl a bucket, you're going to have a whole lot more force than trying to push dirt by opening it. You'll have a little force, but not near this much. So let's look at the setup right quick. I have one reservoir in a schematic. It'll illustrate it, wherever you need to. It's just saying this fluid is going to the reservoir. This fluid is going to a reservoir. Both these lines should have a check valve. I should have a check valve over here, but not all the time necessary because fluid's not going to go back that way. So start at the reservoir, pulling fluid out, going to the two-way valve, and I want to extend or curl the bucket. So I move my joystick so that this two-way valve opens in this direction, allowing this flow to go in to the blind end of the cylinder. So fluid goes in here, builds resistance, overcomes the dirt or the whatever actuator is up against, and curls the bucket. Okay, now when this going in this direction, there's fluid in here from when I opened the bucket. There's fluid left in here. Now this fluid has to go somewhere as this piston is being extended, as this rod is being extended. So it comes out, and it doesn't go, there's a check valve here. It comes out and goes straight to the reservoir because it won't allow the fluid to go through here because this side of the valve is closed at this time. And there's usually a check valve so that the fluid just goes straight to the reservoir. It's under very little pressure when it goes to the reservoir. Okay, now there's fluid left in here from when I extend it, so when I extract, I move my joystick and it opens this valve, and the fluid comes in here and pushes against this side of the piston, and the fluid left over in here from the extending, the fluid during the retracting, the fluid has to come out the same deal through a check valve and into the reservoir. Okay, so it's closed, the valve is closed during this, and there's very little pressure on the fluid coming out now. So once again, we're going to calculate extended force and retracted force, and we're going to use the the calculation for force is pressure times area, and we have given 120 pounds psi. We have two areas to calculate. The rod end area, which is going to be less than the blind end area because the rods, the 2-inch circle, is taking up some of the area on this side, so you're not going to get as much force in retraction as you do in extension. Now let's go down here and look at area right quick. The, the formula for area when we were growing up, or I was pi r squared. You know, pi times the radius squared. Well, that's not the way I've done it, and for a long time I've done it this way. I've taken pi times the diameter squared divided by 4. It allows you to skip a step. Okay, so pi is a constant, and what it's equal to is 3.1416. Now, just so you know, pi is the ratio of the diameter in relation to the circumference, I believe it is. I think that's where the constant pi, but it's used in all circle calculations. So wherever it comes from, it's always 3.1416, as you can see where I've been using it here. So let's calculate the effective area of the cylinder. That's the 4-inch cylinder. So area equals pi times the diameter squared divided by 4, and I'm given that I have a 4-inch cylinder and a 2-inch rod. So the effective area of the cylinder is pi times the diameter squared, right, which is 3.1416 divided by 4 squared, which is times 4 squared, which is 16 divided by 4, and that equals 12.566 square inches. All right, that's the area of the blind side, and I'm going to put it right here, 12.566 square inches. Let me go over that again. The effective area of the cylinder on this side, now on the extended side, is pi times the diameter squared divided by 4. And that's the same thing as 3.1416 times 4, which is diameter squared, which would be 16, which when divided by 4 will equal 12.566 square inches. That's the area of the extended, we call it extend area. So that's the area of the blind side, the extended area. So we got to find the area of the rod. Now, can we take, let's see, what can we do? We can take the area of the extend area, which is 12.566, and subtract the area of the rod, which is 3.1416 right here. You take the area of the rod, 3.1416, times the rod's 2 inches, 2 inches squared, lost my place, area of the rod, pi times 2 squared, which is 4, divided by 4, equals 3.1416 square inches. Now, I know it's the same, looks like the same as pi, but that's a coincidence. It's 3.1416 square inches. So can I just take, to get the annular area, the area of what's left over here, after we take, couldn't I subtract the rod area and get that? That would be called the retract area. So to get that, the rod end area of the cylinder, I would take the extend in, or the effective area of the cylinder, which is without the rod taking up room, which is 12.566 square inches, subtract the rod area, which is 3.1416 square inches, that will give me 9.42 square inches. So that's the rod end area. Do you got that? So now to get the extend force, which is this side, which is which you get to use the whole area of that 4-inch circle, which is 12.566 square inches. And recall that force equals pressure times area. So here we have 120, that's PSI, times 12.566 square inches. That gives us 1,507 92 hundredths, or 0.92 pounds. That's extend force. Now, take the retract force, which again I told you was going to be less. That's because you don't have as much area here, so but you have the same pressure, times 9.42, which is right here. We calculated the rod end by taking the blind end, or the effective area, 12.56, subtracted the rod end area, the area of the rod, which is 3.1416, and we subtracted that from the effective area, 12.56, and that gave us the annular area, which is 9.42 square inches, or that's called the rod end area. It's the area of the same piston, except you've got to take away the area of this 2-inch rod right here. So that's it in a nutshell. We'll probably hit this again. I don't want to go over it. You can pause this video, maybe even copy this down, maybe even check my math, But just remember, area, and the way I calculate it, if you want to go back to pi r squared, good luck with that, but you're welcome to. Or you can take pi, like the guy, remember the guy I like so much that's in the, and I don't care if you do this, the guy that was in the video that talked about the little shortcut, 0.7854, I believe it is, multiplied times the diameter squared. You can do that if you want to, because here's where that comes from. If you just look right here at this little part right here, pi divided by 4, right? So 3.1416. Give me a minute. 3.1416 divided by 4 equals 0.7854. That's that number that cartoon character was using instead of going through pi, the whole formula. You can just take 0.7854, multiply it times the diameter squared, and you're going to get the same thing. You're going to come up with the same thing, or close. It's not going to be exact. Or if you're like me, I still like to go through the effective area, like pi times the diameter squared, divided by 4. And that's where I got, pi times the diameter squared, which was 4, which means 16. You divide that by 4. Right here, we're getting there. Pi times 4 squared divided by 4 equals 12.566. Now, if you take 0.7854 and multiply that times that diameter of 4 squared, let's see what you would get, because I got it up. 4 squared is 16 times 1/6 you get 12.566.4. So that's really close. If you want to do that, I don't care. Did you see what I did? Listen, on these things right here, you send me a note and say, could you go over that again? And you know what I'll do? I'll go over that again. I'll set up a one-on-one with you if that's what you want through the big blue button and we can go over it. Maybe I can even make this clearer, but this is the real, we're starting to get into the nitty gritty of why we're here. And you will see this, you know, this, this is an application of the culmination of the things that we've done before. We've talked about hydraulic system being cascading. In other words, all the components rely on each other. We've learned that fluid pressure in the system increases as resistance to an actuator motion increases. And then when the system pressure overcomes the load on the actuator, we start creating work. And we've also learned and now demonstrated that by increasing the area, we can create a tremendous output force with a little bit of input force. So now we're starting to put all that together. And that's all I got to say about the force, extend force and retract force of a double acting cylinder. Your retract force, your rod end is just always going to be a little bit less. You're going to get a little less force out of it because of the area the rod takes up, and that's that. So we'll talk again soon. We'll talk again soon.